Hello everyone. In this video we're talking about speeding up transactions with SQL Server 2016. My name is Jos de Bruin. I'm a program manager with the data platform team at Microsoft, and I work on a feature called In-Memory OLTP, which is part of SQL Server. And In-Memory OLTP is the technology that allows you to get the most out of SQL Server for your transactional workloads. We initially introduced In-Memory OLTP with SQL Server 2014, and now with 2016, we're making significant improvements both in usability as well as in scalability and performance, so you can get even more out of your SQL Server. So why did we build In-Memory OLTP, and why should you care? Well, we have been looking at trends in hardware, in server hardware, what has been happening over the years, and how should a database system respond to these hardware trends. Now, what we have seen over the last few decades is big increases in memory sizes. You now have many servers that have 2 terabytes, 4 terabytes, up to 12 terabytes of memory available, which means that for many OLTP workloads, it becomes feasible to have the working set in memory at all time. The second main trend is that the modern processors in servers nowadays have many cores. So in a transaction processing workload, you will have many transactions, many operations happening in a database at the same time. And when they try to access the same data or very similar data that lives close together, you get friction between these transactions. That is the hardware side. If we're looking at the demand side from the market, we see over the last few years and looking into the future, a big explosion in growth of data being produced. There are many more devices in the world that are producing data. If you've heard of the Internet of Things, connected cars, these are all producing data. There is an increase in volume of sales of stock markets, for example. And all this data needs to be processed. And there is a demand in the world nowadays. We expect everything to happen instantly, which means you also need instant response from your database when you do a transaction, when you do an operation with your database. And then with an increasingly complex environment, very complex IT environments nowadays, where you have many different types of applications, database systems, there is a wide variety of systems that you need to maintain. And with that, IT expense tends to increase. So with Memory OLTP, we want to improve performance while also keeping the total cost of ownership low. So what is In-Memory OLTP? First off, it is a performance feature. So it is performance optimization technology for OLTP workloads based on memory optimization. Now, what do we mean with memory optimization? It's essentially responding to the modern hardware trends that I mentioned earlier. So first, to answer the trend of multi-core systems, we built an architecture that is highly scalable, that allows you to scale with the number of processors in your server. Essentially, the more hardware you add, the more transaction throughput you can get through innovative log-free database technology. The second aspect is to be able to process operations very quickly. In-Memory OLTP gives you low latency operations. Low latency means a single operation takes very little time. And we do that through very efficient memory optimized data access. When the data lives in memory, it turns out you can access it much more quickly than if you have structures that are optimized for disk access. The second aspect that we have is native compilation, where we take the business logic and compile that down to machine code for very efficient execution. Then with this high scalability and low latency, with customer workloads, we have seen up to 30-fold performance. That's not 30%, no, that is 30-fold improvement in the transaction throughput, meaning the number of operations that the database can process per second. Then you may think, well, this technology is called in-memory. So the data is going to be in memory. So what happens if there is a failure? If my server falls over, somebody trips over the power cord? Well, we built this technology such that the data is fully durable. All the transactions are logged in the transaction log, and there's always a copy on disk that can be used for recovery. So if your server falls over, you have a failure in your data center, need to fail over to a second data center, the data is there. You don't need to worry about that. We give the same durability guarantees as we do for any data in the SQL Server. Then this in-memory database technology is fully integrated in SQL Server. This gives especially great benefit in the total cost of ownership, because you don't need to learn new programming languages, you don't need to learn new tools, you don't need to get used to new client APIs, you don't need to have new methods for database management. All the clients, developer tools, management tools, disaster recovery and HA solutions like backup restore and always-on availability groups, they are fully integrated. In addition, with in-memory OLTP, as part of SQL Server, in the same database, you can have part of your data live in memory and part of your data live on disk. So you are not limited in the total data size by your memory size. You can have, for example, 1 or 2 terabytes of data in memory and 100 terabytes on disk. Now, in-memory OLTP was first released as part of SQL Server 2014. And we already have quite a few customers who are running SQL Server in production. And we see it being used in a wide number of segments. For example, financial, gaming, manufacturing, healthcare. Really, this is not a technology that is very specific for a certain sector or specific for a certain type of application. It is a pretty broad technology that can be widely used for optimizing performance of transactional workloads. And finally, we recently made in-memory OLTP also available in Azure SQL Database in preview for premium databases. Now let's have a look what in-memory OLTP performance looks like with a small demo transactional workload. In this case, ticket reservation workload. This is an insert and select workload, typical read-write workload. And in our scenario here, we start off with running the workload with traditional disk-based tables, the tables that have been in SQL Server forever. Let's go ahead and start the workload. The graph here depicts the number of transactions per second, the number of database operations per second that the system can execute. The driver will try to push the system as hard as possible. In this case, with this workload, we get about 1,000 transactions per second. This might not be sufficient for certain business needs. So maybe we can see how we can speed up this transactional workload. Let me go ahead and stop the workload here. And we can switch to the tools that will help us with actually adopting in-memory OLTP in our workload and see what kind of improvements we can get out of it. So this is SQL Server Management Studio. Everybody who operates a SQL Server database will know this tool and will probably use it on a daily basis. So this is going to be pretty familiar for the folks who are responsible for optimizing performance of database applications. Now, what I can do here is I can pull up a report that is called the Transaction Performance Analysis Report. This report allows me to look at the tables as well as the stored procedures in my database to see which are good candidates for in-memory OLTP. What this graph here shows on the y-axis, the potential performance gain. The higher up you are, the more potential gain you will get from using in-memory. The x-axis shows the potential work needed to adopt in-memory OLTP for these tables. In this case, the table that really stands out is ticket reservation detail. This is a demo workload. This happens to be the only table here. In the typical workloads, you will see a number of tables, and the organization of this graph will really show you which tables you really want to focus your effort on to optimize your performance. So this is the top right quadrant you really want to focus on. Okay, so let's go into the database. So we see here the table that we identified, ticket reservation detail. I right-click on it, and I use the Memory Optimization Advisor. Now, this is the tool that allows me to actually easily move this table to in-memory. There's a migration checklist I can go through. There's additional information I can read up on if I'm interested. I will probably want to copy the data to my new table. I can optionally change indexes if I like. And then let's actually migrate the table. So creating the new table, migrating the data, and we're done. Now let's go back to the workload. We restart the workload, and we see what is the performance using the same workload with the same client driver, no changes on the application side, and we see what is the performance here. So this goes up to about 46,000 transactions per second, about a 45-fold performance improvement, which is a pretty tremendous improvement in this case. Now, of course, this is a demo workload, so this is on the higher end. As I mentioned, in actual production workloads with customers, we see up to about 30-fold performance improvement. And as I mentioned before, we already have quite a few customers benefiting from in-memory OLTP performance with SQL Server 2014. But we're not yet done with in-memory OLTP. With SQL Server 2016, what we set out to do was to make in-memory OLTP a lot easier to use. We made it easier to use in a number of ways. In 2014, we already had some ways to analyze your workload and see how it can benefit from in-memory OLTP. And we made this even easier. It is now very easy with a single click to analyze your workload and see where are your hotspots and where should you be using in-memory OLTP. The second piece we addressed is we made it easier to transition your existing disk-based tables and your traditional stored procedures to in-memory. We did that by adding additional features that are commonly used with disk-based tables, to add that functionality also to memory-optimized tables and as well as natively compiled stored procedures. You can think of features such as foreign keys, triggers, things that are used in many database applications and that you would like to continue using also with in-memory OLTP. So with this set, it is much easier both to develop applications using in-memory OLTP or to adopt in-memory OLTP in your existing applications to speed up the performance. And then once applications are deployed, you have manageability. So we made a number of improvements there as well. We introduced the capability to add and remove indexes to existing tables, as well as change the schema of tables and also change stored procedures after they are deployed to make it much easier to update your application. In addition, we added things like automatic updates of statistics. Just there's one example of a management operation that you would need to do previously that you no longer need to do. So we made it much easier both to develop applications, to migrate applications, as well as to manage applications that leverage in-memory OLTP. The second big improvement that we made was in scalability. Well, you might ask, hey, Jos, you told me that in-memory OLTP is already very fast in 2014. You have this great scalability. So what's up with that? Well, we were not yet satisfied with where we were. We identified some place where we could make further improvements. So first off, we increased the size of the databases. So previously you could have at most 256 gigabytes of data in a single database in your memory optimized tables. We bumped that limit to 2 terabytes, which will really fit most of the current OLTP databases. And then we made further tweaks, further improvements to the overall scalability of the system. You'll see on this slide a couple of numbers. So these are some numbers that we saw recently using SQL Server 2016 on a 4-socket server. So that's not even the biggest class of server around. 1.2 million operations per second that we can handle. These are all update operations. And we can also achieve a sustained throughput of 900 megabytes a second of data that we can process on a single server. So with that, you can see that we can achieve really great scalability on a single server. The other way to look at this is that with in-memory OLTP, you can push your hardware much further than you can with traditional database technology for transaction processing. So this allows you to really do much more with the resource that you have. With the CPU and disks that you have, you can push them much further, get much higher throughput. So that is in-memory OLTP in SQL Server 2016. So why don't you go ahead and download SQL Server 2016 today, give it a spin, see how in-memory OLTP performs for you, and just let us know what you think. If you have any feedback, any questions, just shoot me an email. My email is on the screen. I would always love to hear from anyone about their experiences with my feature. Thank you.